Hello dear students, welcome to the part 4 of chapter 10 circles. Students, till now in this chapter what we have covered, we have studied about the introduction of this chapter, means circle. We have studied the definition, how we can define the circle. Okay, after that some basic terms like radius, center, diameter, arc, segment, okay, chord. So these basic terms we have studied, that how we can define these basic terms. After that students, we have solved exercise 10.1. okay, and in the last part of the video, that is in part 3rd, I have taught you 3 theorems. Okay, the theorems was what? The statement of the theorem was what? The statement was, the first theorem is, if there is a circle, okay, if there is a circle, and in this circle, if 2 chords are there, like it is the chord AB and the chord CD, okay. So the first theorem, the statement of the theorem was what? That equal chords of a circle subtend equal angles at the center. Means this angle, suppose it is 1, and this angle, suppose it is 2, these 2 angles will be equal. When the length of the chords are equal, means if AB is equal to CD, if 2 chords in a circle such that whose length is equal, then the angle they subtend at the center, okay, this point is what? This point is the center of the circle. Then that angles will be equal. This was the theorem first that we have proved in the last part. The second theorem that we have studied is just the converse of it. What was the second theorem? That if in a circle, okay, 2 chords are there, okay, suppose it is AB and it is CD, okay, and the angles subtended by these 2 chords on the center, okay, at the center are equal. Okay, suppose this is 1 and this is 2. Okay, so this time, in the converse of theorem first, this time the statement was what? That if the angles subtended at the center by 2 chords of the circle, then chords will be equal. Okay, means here it was given that if AB is equal to CD, then angle 1 is equal to angle 2. Okay, this was the first theorem. But in this theorem, it is said that if angle 1 is equal to angle 2, then AB is equal to CD. Okay, so these 2 theorems we have studied in the last part, and one more theorem I have told you. That theorem was what? That theorem was that in a circle of center O, okay, if one line is drawn, okay, one perpendicular is drawn of any chord, okay, from the center of the circle, if a perpendicular is drawn to the chord of the circle, then this chord will be bisected by this perpendicular. Okay, from the center of the circle, if we draw the perpendicular at the chord of the circle, then this perpendicular will bisect the chord. Okay, this was the third theorem that we have studied. Okay, students, so today we will start with the converse of this theorem. Okay, once again I am telling you that what was the statement of this theorem, that the perpendicular drawn from the center of the circle to the chord, okay, bisect the chord. Means here AM, here if OM is perpendicular to AB, then AM is equal to MB. Okay, this we have studied. And today we are going to study the converse of this theorem. So this time we are going to study that if AM is equal to MB, so we have to prove that OM is perpendicular to AB. Okay, how we will prove it? Let us see. Students, in theorem third we have studied that if a perpendicular is drawn from the center of the circle to any chord, then chord will be bisected. Okay, but here in the theorem 4 it is the converse of theorem 3. So what should be the statement? The statement should be that if a line is drawn, okay, if a line, I am not saying if a perpendicular is drawn, if a line is drawn to any chord from the center of the circle, okay, such that the chord is bisected, then the line will be what? Then the line will be perpendicular, okay, on the chord. So students, here is the statement: if a line is drawn from the center of the circle to any chord such that the chord is bisected, then the line will be, okay, here it is, then the line will be perpendicular to chord. Okay, this we have to do. Means here you can see, suppose if it is the circle, okay, and in this circle this is the center O, okay, and this is the chord, suppose this is the chord AB, okay. One line is drawn from this center O, one line is drawn from this center O such that it bisects the chord, means this AM is equal to MB. So we have to prove that this angle and this angle, okay, is 90 degree. Okay, 90 degree means it is proved that OM is perpendicular to AB. Okay, so how we are going to prove it, students? Let us see. Simply, firstly we write that what is given. Okay, firstly we write that what is given. So students will write that a circle C O comma R. O comma R means circle of center O, radius R. Okay, a circle C O comma R in which OM is a line drawn to chord AB such that AM is equal to MB. Okay. Now friends, what is to prove? We have to prove that the line OM is perpendicular to the chord AB. Okay. Since it is the converse of the previous theorem, so this time we have to prove that the line OM is perpendicular to the chord AB. Okay. So how will we prove it, students? Firstly, we have to do some construction. Okay, as we have done in the last theorem. What construction we have to do? We have to join OA and OB. Okay, we have to join OA and OB. Now in the proof part, what will write? How will prove it? Let us see. Students, if we have joined OA and OB, okay, if we have joined OA and OB, so here you are getting two triangles. The one is triangle AMO and the second one is triangle BMO. We have to prove that these angles are of 90 degree. Okay, this we have to prove. How will prove it, students? See, firstly, as we have done in the last question, I have told you that if two triangles are there and somehow we prove them that the triangles are congruent, then if they are congruent, then their corresponding parts should be equal. Okay, see, here it is 90 degree, here it is 90 degree, means they are equal. Okay, so the first step to prove that this angle is 90 degree, that these two angles are equal. Okay, so after proving that the triangles are congruent, the first step will complete that these angles are equal. Okay, students, so if these angles are equal and they are on the line, so we will use the linear pair of angles. Okay, we will use the concept of linear pair. Okay, so firstly, here we have to prove that these angles are 90 degree. So let us suppose that this is angle 1 and this is angle 2. Okay, let us suppose that this is angle 1 and this is angle 2. Now students, we will write that in triangles AMO and BMO, in these two triangles, see students, here if we have joined OA and OB, so both are the radius of the triangles. Okay, so what property we are having? We are having the side AM is equal to MB. Okay, so one side we are having side AO is equal to BO. So again we are having the side. Okay, and the side OM is common for both of the triangles. Means we are having the criteria side, side, side. Okay, so this we can use, that side, side, side. So let us see. Firstly, you write that AM is equal to MB. Okay, how it is given in the question? It is given in the statement of the theorem. Then the side, second side is what? It is AO is equal to OB. Okay, why they are equal? Because both are the radius of the circle. Okay, and the third one is OM is equal to OM. How we can say that they are equal? You can see that both are common for the triangles. Okay, so students, by side criteria, we can say that triangle AMO is congruent to triangle BNO. Okay, so if these two triangles are congruent, then if these two triangles are congruent, then by CPCT, what we can say? By CPCT, we can say that angle 1 is equal to angle 2. See students, in the figure we have supposed that angle AMO is angle 1 and angle BMO is angle 2. Okay, so here we have got that angle 1 is equal to angle 2. But angle 1 plus angle 2 is equal to 180 degree. How we can write that angle 1 plus angle 2 is equal to 180 degree because of the linear pair angles. Okay, we know that if there is a line, okay, and one more ray is there, okay, then the sum of these two angles will be 180 degree because they are the linear pair of angles. I have taught you this in chapter 6, lines and angles. Okay, so by the property of linear pair angles, the sum of these two angles will be 180 degree. Okay, from here we can put at the place of angle 2, we can put angle 1. Okay, is equal to 180 degree. See here, angle 1 is equal to angle 2. So at the place of angle 2 we can put angle 1. So at the place of angle 2 I have put angle 1. Now angle 1 plus angle 1 180 degree. So here angle 1 will be what? Angle 1 will be, when 2 will divide this 180 degree, it will be 90 degree. Okay students? And if angle 1 is equal to 90 degree, then it will imply that angle 2 is also 90 degree. Okay? Means angle 1, angle 2 both are equal. So they both are equal to 90 degree. Now students, if this angle becomes 90 degree, then it will imply that the OM side is perpendicular to AB. Okay, the line OM is perpendicular to AB, and which was to prove here. Okay, which was to prove here. So see students, this is the proof of the theorem that if a line is drawn from the center to any chord such that the line bisects the chord, then the line will be perpendicular to the chord of the circle. Okay, this is the proof how you can prove this theorem. Okay, so firstly just note it down and then we will start the next topic. Now students, we'll see the questions of exercise 10.3. Okay, in exercise 10.2 I have explained you in the last part of the video that there is only two theorems, okay, and which was based upon the theorem 1 and theorem 2. In exercise 10.2 only two questions are there which was based upon the theorem 1 and theorem 2. Okay, now coming to exercise 10.3, students, keep your books with you. Okay, keep your NCERT books with you. So the first question is, draw different pairs of circle. How many points does each pair have in common? What is the maximum number of common points? Okay students, so we have to draw some pairs of circle and we have to tell that how many points the pairs of the circles are having common. Okay, so students, here three cases will be there. Okay, and the cases are what? And the cases are, see, it is the solution of first question. Okay, so three cases will arise. The first case is what? When no point is common. Okay, we have to draw the pairs of circle. Okay, and three cases are possible. In that, the first case is when no point is common. So see students, if two circles are such that they are having no points as common, you can see that both the circles are little bit distant to each other. Okay, so they will have no points as common. Okay, one more thing, one more case. Suppose in case first, this is the first figure, and one more figure is possible that suppose this is one circle, and in this circle one more circle is there, but they are not concentric. They are not concentric means this is the center of the greater circle, and this is the center of the smaller circle. Okay, so again in these two circles, okay, no point is common. Okay, so this is the case when no point is common. What is the second case? Means the possible second case is when one point is common. When one point is common. So students, if one point is common, then the figure will be like, suppose this is a circle, okay, and one more circle is there which is just touching this circle, okay, at one point. Okay, so at one point this circle and this circle touches each other. Okay, so this is the possible case, the first figure of case second. And one more case is possible, that if two circles are there and one circle is just touching this circle at one point, but it is in the circle. Okay, this is the center O of the greater circle and this is the center O dash of the smaller circle. Okay, but they are touching at one point. Suppose this point is P and here this point is Q. Okay, so these two circles are touching at point Q and these two circles are touching at point P. Means the circles are having only one point as common. Okay, here you can see that no point is common. Here you can see that one point is common. Now the last case third. Case third is that when two points are common. When two points are common. So if 2 points are common, then you will get the figure like both the circles are intersecting each other. Okay, so if two circles intersecting each other, so they will have 2 points as common, that one point P and one point Q. So students, one more question arises from this question, that how many maximum points two circles can have as common. So the answer will be 2. Okay, only in the case of congruency, that if two circles are congruent to each other and also they lie on each other, then only in that case infinitely many points will be there. Okay, but in general what we say, that two circles can have maximum 2 points as common, as you can see from in this figure. Okay, so students, all the pairs we have seen here, no points were common. Here 1 point as common and here 2 points as common. Okay, so now you can note it down. It is the solution of first question of exercise 10.3. Coming to the second question, students. Second question is, suppose you are given a circle. Give a construction to find its center. Means, students, if a circle is given to you, but it is not known that where is the center of that circle. Means, we have to find the center of the circle. Okay, how we can find? Let us see. See students, suppose this is the circle which is given to you. Okay, and where is the center of the circle? It is not known, but you have to find it. Okay, so how you will find it, students? You have to give construction. It is said in the question. Okay, so how we can give the construction? See students, firstly we have to make, okay, 2 chords. Anywhere in this circle we have to make 2 chords. Okay, suppose I have made the chord AB and the chord CD. Okay, these 2 chords I have made in this circle. So the first step is what? Step 1. Step 1 is draw 2 chords AB and CD of the circle, of the given circle, of the given circle. Okay, so just we have made 2 chords of the given circle. The one is AB and the second one is CD. Okay, after that, students, step 2 is what? Step 2 is we have to draw the perpendicular bisector of these chords. Okay, we have to draw the perpendicular bisector of these chords Students, in the previous classes, you have studied that how to draw the perpendicular bisector on a given line. Okay, suppose this is a line. Okay, I am just reminding you that how to draw perpendicular bisector. Suppose we are having a line AB. Okay, and it is said that draw the perpendicular bisector of AB. So how you draw the perpendicular bisector of AB? You just put your compass, okay, at point A, and then take a radius more than half of AB, okay, and you have to just make an arc in the upside and in the downside, okay, and the same thing you will repeat from point B. Okay, just put your compass here, and from the same radius just make two arcs like this. Okay, and here are two intersecting points. Okay, you are getting two intersecting points and you have to join that points. Okay, so when you will join these 2 points, so wherever this line intersect the AB, okay, that point will be the midpoint of AB. Means here you will get AM is equal to MB, as well as it is perpendicular to this side AB. Okay, students, so this is the method that we have learned in your previous classes, that how to draw perpendicular bisector of a line. Okay, so here students, you have to draw the perpendicular bisector of the chord AB as well as the chord CD. Okay, so in the second step you write that draw the perpendicular bisector, draw the perpendicular bisector of AB and CD. Okay, so students, how you will draw the perpendicular bisector of AB and CD? See, just put your compass at point A and take more than half distance, okay, of AB, and of that radius you have to draw 2 arcs. Okay, students, so when you will draw, and same thing you have to repeat from point B. Okay, so you will get the line like this. Okay, you will get the line like this. Okay, when you will make it in your copy, you will get the perfect figure. Okay, and the CD, then again more than half distance you have to make 2 arcs and repeat it from point B, and again you will get a line. Students, wherever these perpendicular bisectors intersect each other, okay, suppose they are intersecting at this point, then this point will be the center of the circle. Okay, so here you write in step third we will write that the point of intersection okay, of perpendicular bisectors of AB and CD is the required point, or you can say is the required center of the circle. Is the required center of the circle. Okay, students, so the method is very easy. Only you have to do what? You have to draw 2 chords of the circle. Okay, and after that you have to draw the perpendicular bisectors of these chords, and wherever they intersect each other, that point will be the center of the circle. Okay students, so these steps of construction you have to write, and you have to make this figure also, and the construction you will draw only by the pencil, and the perpendicular bisector you will draw by the help of the compass. Okay students, so as we have done in the last classes that how to construct any figure, okay, in construction type of chapter, so this is the question also which is related to the construction type of question. Okay, so just make proper figure in your copy, and you have to write the steps of construction also. Okay, so students, just pause the video and note it down. So students, as I have told you that whatever the theorems I have taught you, till now 4 theorems I have taught you in this chapter. Okay, and all the 4 theorems are very important. They are important. Why? They can be asked directly in the form of questions in the examination, or they can be asked, okay, the questions can be asked on the basis of that results. Okay, so anyhow you have to remember the statement, you have to understand the statement of the theorems, okay, as well as you have to do the practice of these type of questions. Okay, so just practice it and make proper NCERT fair copy, so that, okay, so that in the preparation time you will not face any type of problem. Okay students, so this is enough for today. Thank you students.